to meet increased customer demand, our customer built a new distribution center. They set the new area up in the same fashion as their past distribution centers. After a few months of operation, they discovered that the distribution center could not meet the demand of all the orders that were coming in on a daily basis, and expenses were increasing. They tried increasing staff in all the different areas, but were still unable to meet the requirements or affect the system throughput. Consequently, they decided to build a simulation model of the facility to try to identify where the bottlenecks were. In the first model, you will see the CAD layout of the facility in its current state. It has bulk pick areas, carousels, flow racks, and an automatic dispensing system. The order types were defined by the areas picked from and the size of the order. They had good data that depicted the volume for each order type. They decided to look at a typical volume day and a heavy volume day. All large orders were picked from the shelves and routed to bulk packing. All orders that had to go through the carousels, flow racks, or automatic would be placed in totes and introduced to the conveyor system upstream from the carousels. They would then be diverted to the appropriate areas and eventually sent to the print pack area at the end of the conveyor. The totes would circulate on the print pack conveyor until an operator pulled it off the line. The operator would then scan the items, print a label, print an invoice, put the items in a box, then send the box down to shipping. With the first runs of the model, it was determined that the conveyor system was the bottleneck. As a result, it didn't matter how many operators they added. The conveyor was limiting the total throughput. The shift supervisors validated that this was what was happening in the daily operations. To resolve the problem, we suggested that they change the way the totes were introduced to the conveyor system. Instead of introducing all of the totes at the beginning of the line, upstream from the carousels, they would introduce the totes just upstream from the first pick area on the conveyor. This resulted in 2 new tote induction areas, one at the flow rack area and one upstream of the automatic area. The Pro Model simulation model predicted that this change would increase the capacity of the system by 10%. A good increase, but still not enough to meet the current order demand. As a result, they immediately implemented the change in their WMS system and saw a daily system throughput increase from 5% to 14%. However, they still were unable to fill all the orders in a shift. In studying the data provided by the new model, they were able to identify the next areas that they could change to increase throughput. The model showed that with the new tote induction locations, the bottleneck was shifted from the conveyor system to the print pack area. They reviewed a number of alternatives to increase the capacity of the area and determined that the best approach would be to break the area into 2 separate operations: a printing/order verification area and a packing area. To accomplish this, they would need to create printing stations, and they were not sure of what the design of the stations should be and how many would be required, as well as fit them into the space currently available. To help determine the best design and throughput capability of the printing stations, they built a detailed model of the printing station design, showing the trade-offs of different configurations. This helped them determine the optimal design and determine the number of stations that would be required to meet the present and future demand. The process involved an operator pulling a tote from the conveyor, entering and scanning the tote ID into the computer, scanning the items in the tote, printing a label, printing an invoice, putting inserts in the tote, putting the label into the tote, folding the invoice and putting it into the tote, then putting the tote back on the conveyor, going to packaging and shipping area. The model contains 2 equipment configurations. The first is a single printer station, which would allow for one operator to work on one tote at a time. The second idea is a double printer station, which would allow for one operator to work on 2 totes at a time. The simulation results showed that the difference in throughput would be nearly 2 times more with the double printer station. Furthermore, the utilization of the operator would be about 92% versus a maximum of 46% in the single printer station option. The data clearly showed the two-printer option was best due to the increase in saved space, and the throughput and operator utilization far outweighed the cost of the additional equipment. The conveyor layout was redesigned in AutoCAD to allow space for the new printer stations and to determine the maximum number of stations that would be required during operation. The original CAD model was modified to reflect the new facility layout. After running a number of order scheduling scenarios, the design was refined to meet future projected demand requirements and would support up to 30% more demand if needed. Based on our findings, the proposed system has been implemented. Pro model's predictions of the model performance were within 5% of the actual operation. The final outcome is they are now able to meet 100% of the order requirements and have more capacity if required. In addition to the original system setup, they continually use the model to help determine the staffing requirements and shift schedules for each area depending on the order profiles. Pro Model's simulation capabilities combined with Autodesk's CAD capabilities create a powerful, flexible, and easy-to-use toolset for creating digital twins.